Sari Starkey-Lanham, you had some amazing questions, but Svetlana Hansen, we're going to get to yours. So Svetlana, she's been a longtime listener, many years now, of participating in the podcast. So she's a senior software engineer creating real-time network engineering solutions for NASA spacecraft, which is a pretty cool job.
Very
and
cool.
So unsurprising to hear somebody working at the frontier of space asking a question like, where are we going with the future of scientific computing? Where are we going with the future of scientific computing and Python libraries?
Great question. I think I was capturing it when I talked about essentially the compiler framework. I see the future in something like Torch Compile, in Numba, in JAX. Now, it's not there yet. I wish I could tell you, just do this. I would say, though, write your code at a higher level. Like if you're writing low-level loops, question why. You should be writing array code, right? I still think the future is array-oriented computing. Write your code with here's an array or a data frame or database computing, because then it enables you to you're writing code in a way that can be optimized by compilers in the future, as opposed to the more detailed you write it, like, oh, I'm writing this loop and grabbing that element of this loop, and the more detailed you're doing that, the harder. Today you can do it. High-level array computing, write a Numba ufunc, write a ufunc to do the low-level code you can't just do with operations that exist. You do that, and that will be future-proofed for the future. And it works today. And in the future, you can take advantage of new innovations in compilation technology. So where we're going, I think, is a world where, one, people write at a higher level, and the code is faster still. It's going to take time to get there still, but I think there's ways to do it today. Then two, I do think generative AI is going to help us with better human-computer interfaces so that more people will write even higher level, right? You can just use English language to express your ideas. And then that'll translate to frameworks that will spell that out, that then get edited. And depending on where you are in the cycle of the innovation cycle, you'll either be operating at the very most exploratory part of writing human language and interacting with the visuals, or supporting the technical libraries that emerge from that exercise and making sure that they keep working, or even building frameworks at the lowest level. You have a whole career path, and you can kind of go up and down if you'd like. But I really see a world where I really want experts to be able to think about their problem. Python's been popular because it got out of the way of people, let them think about their problem instead of their pointer arithmetic and their semicolon placement, right? They could just think about their problem. And that's still needed. Like, we have scientists solving hard problems, thinking at a big scale, and I want to support it. And I think you can. So, but keep track of the compile world. Recognize that's where, kind of ask where this run is happening. Is there an optimizer somewhere that's able to take your code and then make it faster? And if the answer is it's nowhere, then okay, maybe you should be thinking about ways to do that, or looking for cooperation paths to do that with. Then otherwise, it's kind of still frothy. There's still a lot of interoperability, I think, is still, and data. The other thing I would say is, don't lock your data up in things you don't know. Like, make sure you know, or a spec exists, a public spec exists for your data. It's really, the future is going to be bad for you if your data is locked behind a proprietary format that is not available by lots of people. So that's the other, I guess, thing I would say. And you can use a proprietary database. You can use a compute engine that you pay money for. That's fine. But just make sure the data you rely on has some existence in a public forum.